Yesterday we reviewed factoring. Today we're going to solve our equations using factoring. So when we solve, what does that mean? What are we solving for? We're solving for the very important parts of a quadratic, which are the roots, which are also called solutions, which are also called zeros, which are x-intercepts. Now, the reason they're called zeros is because that's when y is 0. The x-intercept is what is x when y is 0. So, f of x takes the place of y. Therefore, I want to know when f of x or y is 0. First, I have to factor this. Yesterday we reviewed difference of two squares. This is a difference because there's a minus. The only way to get x squared is x and x. What's the square root of 16? 4. We have to have 1 plus and 1 minus to make the x term in the middle 0 out. The only way two things can multiply to equal 0 is if one of them is 0. Maybe they're both 0. So I'm going to make two separate equations here. I'm going to take my first parentheses, x plus 4, and set it equal to 0. Then I'm going to take my second parentheses, x minus 4, and set it equal to 0. Well, these are simple to solve. You just take away 4, and x equals negative 4. Add 4, x equals positive 4. So what are your two roots? Negative 4 and positive 4. We can write them as points, negative 4, 0, and positive 4, 0, or we can put them in brackets to show that they're the two roots, the two x-intercepts. Do you see that perhaps this was just the opposite? Our roots are the opposite of what are in parentheses. Hopefully you can see that. That's a little shortcut. So let's try another one. I want to know when f of x is 0. This one's already factored for us. So all we have to do, let's separate these, is set our two factors equal to 0. So either this one, 3x equals 0, not a great pen, or this one, x minus 6 equals 0. So if this one's 0, divide by 3, x is 0, because 0 divided by anything is still 0. If this one is 0, x is 6. Do you see how it's the opposite of this, 6, and then this just has to be 0. So what are my roots on this one? 0 and 6. The reason we would solve by factoring is sometimes we can't see them on the graph easily, like we've done with some other ones in the past, and sometimes they come out to be decimals. We're not going to see that today, but we'll see it as we move on through here, doing some more. And sometimes our graphs are too big. It's just too hard to find them. So let's look at another one, number 3. So I want to know when this is 0. First, I have to set it equal to 0, and I have to factor it. So I want the two numbers that multiply to negative 5 but add to positive 4. That's going to have to be negative 1 and positive 5. 1 and 5 are the only two things that multiply to 5. But to get negative, one of them has to be negative. To add to a positive 4, the bigger one has to be positive. So we're going to have minus 1 and positive 5. Now, can I take a shortcut here? Because as we've seen, when I set each of these to 0 and solve, I'm just going to get the opposite. Our roots are positive 1 and negative 5. Now, this is related to, do you remember in vertex form, the x value of the vertex in parentheses was always the opposite? It's kind of related to that because it's moving the opposite direction. So far, all we've learned about one that has a number besides 1 in the beginning is that it has a GCF. We haven't learned, we will learn tomorrow, but so far we've only learned to do GCFs. So the GCF is 3, so let's divide them all by 3, and we get x squared minus 8x plus 12. And I want this to equal 0. So let's factor this. Now remember that when it ends with a positive, your signs have to be the same. Since the middle's negative, they have to both be minus. So what are the two factors of 12 that add to negative 8? It's going to be negative 2 and negative 6. When you multiply them, you get positive 12. When you add them, you get negative 8. So 3 is a factor, but there's no way 3 can equal to 0. So we don't even worry about that. We just toss that out. And here, if you set these to 0 and solved, you would get the opposite. You would get positive 2 and positive 6. So now let's move on to this one. It's not equal to y. It's not equal to f of x. Remember that we cannot solve until it's equal to 0. How do you make this equal to 0? So I've got to take away the 10 to get it to the other side of the equal sign. I can't take away 10 from the x squared. I can't take it from the 9x. So all I really do is write it at the end. So shortcut, I moved the 10 by doing the opposite. Let's factor. Remember that if it ends in a negative, you have to have one of each. One positive, one negative. I want the factors of negative 10 that add to 9. That's going to be negative 1 and positive 10. And then I'm going to do the opposite for the factors, and I'm going to get negative 10 and positive 1. I mean, for the roots. Okay, here's something that I can factor. They're both positives. So this has to be both positives. You want what multiplies to 36 but adds to 13. That's going to be 4 and 9. But I want to solve for the roots. That means I want to set it equal to 0. It wasn't set equal to 0, but in order to solve it, we have to set it equal to 0. So if x plus 4 is 0, x plus 9 is 0, you know that you would do the opposite. Just reminding you here of the solving process. You could have done the shortcut, but I just wanted to remind you. So there's the roots.